Okay, guys, so we're going to spend a little bit more time talking about Lewis dot structures and how what they are is they're a way to represent the valence electrons and show how those valence electrons can be used to make a bond between the metal cation and the non-metal anion. Okay, so we just said that Lewis dot structures are used to show the bond, okay, between metals and non-metals in an ionic compound. Okay, that's the purpose of them, at least in our class, so that you can see kind of how a bond is actually made. Okay, so a single bond, which is really the only electron Lewis dot structures that we're going to draw, a single bond is represented by two electrons. Okay, so a bond contains two electrons. That's what makes a bond. So one of those electrons is going to come from the cation, so then that means that the other electron is going to come from the anion. Okay, and you have seen that because we have done some practice. Okay, so a double bond, which we have a couple problems in the practice that you're going to do that are going to show you a double bond, but that's exactly what it sounds like. It's double what a single bond is. So that means that's represented by 4 electrons. So it's even more electrons that are making the bond. So it's a tighter bond. So that's going to be 2 electrons then that come from the cation, so then 2 would be coming from the anion. Okay, so let's work on some example problems that are going to be like the practice that you're going to do on the back side of this page. Okay, so one of the types of problems that you'll have gives you the chemical name of the ionic compound. So say for example we have aluminum bromide. So in order to draw a Lewis dot structure showing the bonds between the aluminum and the bromine, you have to know how many atoms of aluminum are in that compound and how many atoms of bromine, okay, are bonded together in that compound. So the way we know that is if we write out the chemical formula for aluminum bromide. Okay, so that's where our first step comes in, is that we're going to have to go back to our crisscross method to determine what the chemical formula is for aluminum bromide. Okay, so this should be review for you. So our aluminum, so remember we have to figure the charges and use our crisscross from there. So aluminum has a 3+ charge and bromine has a -1 charge. Okay, so when we do our crisscrossing, then that means the -1 is going to imply that there's going to be 1 atom of aluminum, and then the 3 is going to imply that we're going to have 3 atoms of bromine. Okay, so then that means our chemical formula is going to look like this. So AlBr3. Okay, so there's our chemical formula. So then our second step is you have to know the number of atoms you have of each element in the compound. So that's as simple as looking at the chemical formula and looking at the numbers that are next to each element. Okay, that's exactly what those numbers represent, is the number of atoms of each element that you have. So for aluminum, if there's nothing written next to it, we know that implies that there is just 1 atom of aluminum. Okay, so we know we have 1 atom of aluminum. Okay, and so the 3 next to the bromine means that we're going to have 3 atoms of bromine. So in the ionic compound aluminum bromide, we have 1 atom of aluminum bonded to 3 atoms of bromine. Okay, so that means in our Lewis dot structure you should have 3 Brs and 1 Al. So the third step, so I kind of split the actual drawing of the electron dot structure up into 2 different steps to make it a little bit easier for you. So for the third step, you would just draw the Lewis dot structure for all of the atoms of each element. Okay, so we know we got 1 atom of aluminum, and we know we have 3 atoms of bromine. So let's just draw them all separately, not bonded to each other, because I know that you know how to do that, and then we'll get into how we show the bonds. Okay, so if we're drawing 1 atom of aluminum, so just 1 aluminum, that's going to be Al, and we know it has 3 valence electrons. Okay, so this part right here, guys, some people in other classes were getting confused, and they were trying to use the 3 plus charge as the reason why you were drawing the 3 electrons around it. That's not what that is. These are the 3 valence electrons. So there's our 1 atom of aluminum. So we have 3 atoms of bromine. Okay, so that means we're going to have 3 electron dot structures of bromine. Okay, so bromine has 7 valence electrons. So if we're drawing an electron dot structure, okay, it's going to look like this for one of the atoms of bromine. Okay, so the other 2 are going to look identical to it. They're, of course, going to have 7. Okay, so this is all of the atoms that are in the compound of aluminum bromide. It's just we're showing them all sort of separate from each other and not connected by a bond. Okay, so for step 4, we're going to determine how the electrons can pair to make bonds to form an ionic compound. Okay, so we talked about how you can't have any lonely electrons. Okay, they have to have a friend. Okay, so we have, if we just have them separate from each other, we have 1 here, 1 lonely one here. Oops, I forgot to draw this one. And you have 1 lonely one here, and here, and here, and here. Okay, so all these ones that I've underlined in purple are by themselves, and they want a friend. Okay, so they're going to take part in a bond. So for step 4, really, you don't have to draw anything down here necessarily. We can just use the separate atoms we've drawn up here. Okay, so if we're going to determine how the electrons can pair, I think the easiest way to show that is by drawing a line that shows, or an arrow, I guess, that shows the electrons that are going to bond with each other. Okay, so we have 3 electrons from aluminum, okay, and 3 electrons that are lonely from bromine. Okay, so if we're making this fit together like a puzzle so that all the electrons have a friend, then we're going to have that 1 electron from aluminum maybe come over here and bond with this bromine's lonely electron. Then maybe this lonely electron from aluminum will come over here and bond with this lonely electron on bromine. Okay, and then I think you get the pattern. This one is going to come over here and bond right next to this one for this bromine. Okay, so for step 5 then, we're going to draw the actual Lewis dot structure. So we're pretty much just going to combine, okay, this aluminum and stick the bromines right next to it. Okay, so I'm still going to color code it to make it a little bit easier for you to see. So for step 5, then you would have, let's see, what color should we use? All right. Okay, so for aluminum, we would draw its 3, and then we draw the bromines right next to it. Okay, so this is our completed electron dot structure for aluminum bromide. Okay, sorry, that got a little kind of up into the font. Okay, so this is your completed electron dot structure. Okay, not this. Okay, this is great. This shows us that, you know, where all these electrons, which electrons are going to pair with which, okay, from aluminum to bromine, but that's not the actual structure. This is the actual structure right here. So the electrons that they're sharing with each other, so this purple and pink one here represents a bond. So this is an ionic bond. Okay, these 2 electrons represent an ionic bond, and these 2 electrons represent an ionic bond. Okay, so the electrons they share are the ones that make the bond. And we just said that 2 electrons are what make a bond. Okay, so let's look at a practice problem. So you have sodium sulfide. So remember, our first step is to figure out what your chemical formula is. Okay, so step 1, we have sodium that we know has a +1 charge, and we have the sulfur that we know has a 2- charge. So we crisscross, the 2 goes to the Na, okay, then to the S, the 1 will go to the S. So our final formula is going to be Na2S, okay? So that means we're going to have 2 atoms of sodium, and we're going to have 1 atom of sulfur. Okay, so now we can go on to drawing the electron Lewis dot structures for each atom that's in sodium sulfide compound. Okay, so we draw 2 atoms of sodium. So we have Na, Na, so we're looking at the valence electrons again, remember. So we have 2 atoms of sodium, so here's our 2, and they have 1 valence electron, so we draw just 1 dot next to each of them. And then our sulfur, sulfur has 6, so we have 1, 2, 3, 4, 5, 6. Okay, so we have all of our atoms drawn, so then we just fit them together. Basically, kind of like a puzzle, make sure everything's paired. So this electron from sodium goes over here with this right next to this electron for sulfur, and then so maybe this electron for sodium can come right next to this lonely electron from sulfur. Okay, so that makes our final structure look like this. And we're going to draw everything right next to each other so that we can really show the bond. So it looks like this. Okay, so this is our final electron dot structure for sodium sulfide. Okay, I know that was a kind of a long video, but that's it, and hopefully that should help you be able to do all these practice problems.